Advanced Algebra, Chapter 7, Lesson 2, and we're going to continue working with radicals, and we're going to look at how we multiply and how we divide radical expressions. So we'll look at those separately, and then we'll look at rationalizing the denominator. To multiply expressions, this little chart up here kind of gives you a walkthrough on why or how we can multiply radicals. Basically, there's only a couple rules to remember, and that is that the radicands, or the indexes, excuse me, must be the same. So I can only multiply radicals that have the same index. I cannot multiply a square root of 7 times the cube root of 31. Okay, I can't do that. One's a square index, one's a cube index. So that's really the only rule we have to remember. The only other thing I want to remind you of is that when we're multiplying radicals together, and let's say we have numbers in front of the radicals, so let's say we have 3 radical 2, and we're going to multiply that times 7 radical 7, let's say. That radicals are kind of like variables, and we treat them like variables with many of the operations that we do, and we'll talk more about that when we're adding them. But when we're multiplying them, we can multiply the numbers that are outside the radicals together, and then we can multiply the radicands together. But you can't mix a radicand, a number under the radical, and multiply it by something that's outside the radical. That's not a radicand. So you can't mix a radicand with a non-radicand, and you can't mix a non-radicand with a radicand. So basically, numbers that are outside we can multiply together. So the 3 times the 7 would be 21 in this case. And then the radicands, as long as the index is the same, we can multiply together. And so this would be 21 square root of 14 for this example. So if we keep those things in mind, then multiplying these radicands is fairly straightforward. Now, when we're multiplying these radicals, the radicands from each expression can be put underneath one radical sign. So radical 16 times radical 9 can be rewritten as radical 16 times 9. I can then multiply the 16 times the 9 together to get 144, and then determine the square root of 144, which is 12. Now, the problem with multiplying these numbers together before you simplify, it creates and can create some pretty large numbers that you're then going to have to find the root for. I think it's easier to simplify these radicals first, thus you're working with smaller numbers rather than these larger numbers. Let me show you what I mean. If we multiply the 16 times the 9, we get 144, and the square root of 144 is 12. However, if I simplify these beforehand, look what numbers I get to work with. I take the square root of 16 is 4, and I take the square root of 9 is 3. I'm multiplying 4 times 3, and I can get 12. Multiplying 4 times 3, most of you could do in your head. 16 times 9, you probably took out your calculator to do that. And then you probably took out your calculator to do the square root of 144, which you don't want to do because if it's not a perfect square, we don't want a decimal answer, so you're going to have to do your upside down division or prime factorization in order to simplify this bigger number. So I think it's easier to simplify before you multiply, and you're going to hear me say that a lot. Simplify before you multiply. You can save yourself some headaches, and you can work with some smaller numbers, which are obviously easier to work with. So let's do an example where we have some numerical and variable radicands together and show you how this works. So we're asked to multiply this cube root here and this cube root, and notice that it says assume that all the variables are positive. What does that mean? Why would they put those instructions there? What are they trying to tell me? Well, you remember from our discussion of absolute radicals, if the index is even and I have an odd power root, I have to use absolute value symbols to make sure that negative values substituted in produce positive roots. Well, if we can assume that all of the variables are positive, meaning we're only going to put in positive numbers for the variables, then I don't have to worry about that scenario. So when I receive these instructions, I can disregard the use, or I don't need to use the absolute value symbols in order to in my final answer. So note those instructions so I do not have to use absolute value symbols. Now, this example is from your book, and they walk you through this, putting them all underneath, and they do all the prime factorization underneath and all of that. I'm going to skip that and show you how hopefully simplifying first make things a little bit easier. So the first thing I'm going to do is I'm going to take this first radicand here and I'm going to simplify it. So I have the cube root of 54 x squared y cubed. So if I simplify that first, I'll do my prime factorization with 54. I have 2 and 27. Now I could keep going doing 3's, but I recognize this as a perfect cube, and I know that the perfect cube root of that, or the cube root of that, is 3. So I don't have to go any further. 54 is going to be 3 cube root of 2 simplified. So I'm going to use that. So I have 3, and then I still have the cube root of 2. All right? That takes care of the 54. Now the 3 cube root of x squared, 3 does not go into x squared at all, so x squared is left underneath. 3 into the 3 of the y comes out as 1 with no remainder, so this is the simplified version of this cube root. And then I want to simplify this cube root over here, doing the same thing that I learned in the previous lesson. Alright, 5, there is no cube root of 5, so it stays underneath. 3 goes into this 3 one time, so I have one group of 3 with none left over. And then 3 into the 4 goes one time, and then I have 1 left over. So this is the simplified version of this. So now I simply multiply these values that are on the outside together, and then I multiply these radicands together to get my final answer. So 3 times 1 over here is 3. I have x, or nothing times x, so I have x, or 1 times x, and then y times y is y squared. And then I have my radicand. I can multiply together, so I have the 2 and the 5, so that's times 2 times 5 is 10. I have x squared times no more x's over here, so that's x squared. And I don't have any y's over here times this one y over here. So this would be the two radicals multiplied together, simplifying first, and then multiplying them together. Alright, so let me scroll down here and see, and you can see I have the exact same answer that they have, simplifying first. So you can do that either way. I would again suggest simplifying first and then multiplying. I think that's easier. I will do a video where I do a number of examples, so you can check that out if you need more help with these.